Good morning, students. So let's start with today's Google Classroom. So today's Google Classroom, it is about the paper name, that is a physical chemistry, and a physical chemistry it has a paper number is 8, and the name of the chapter we have to discuss in this lecture or in this Google Classroom is that is thermodynamics. Thermodynamics first. From previous 9 to 10 Google Classroom, we have studying the chapter that is unit first, that is thermodynamics. In every Google Classroom, we have studied the various topics. Various topics are discussed in what are the important topics are discussed in all the Google Classrooms. Today, we studied another important or the interesting topic from the chapter, that is thermodynamics. So the topic we have to discuss today are under isothermal and adiabatic conditions for the reversible process. That is mean by what are the conditions, that is isothermal condition, adiabatic conditions for the reversible process. How these conditions are applied to the reversible process, at what temperature, pressure, or the all the other things we have to discuss in this today's Google Classroom. Before to start with this today's Google Classroom and the today's topic, in a previous Google Classroom we have already discussed that what is meant by thermodynamics, what are the thermodynamic terms or the important thermodynamic terms which are very important for the studying the thermodynamics. So first, what is the definition of the thermodynamic? In every Google Classroom, I have given you the idea about the what is meant by thermodynamic. That is, the thermodynamic, it is a branch of the physics, deals with heat and temperature and their relation to the energy, work, radiation, and the properties of the matter. The behavior of these quantities is governed by the four laws of the thermodynamics, that is first law, second law, and the third law, and the fourth law. So these are by according to these four law, thermodynamics is explained. All the terms are the explained. Then there are the some terms which are the very useful for the understanding of the thermodynamic. That is the system. Then system, it is also divided into the various types. There is open system, closed system, isolated system. Then properties, intensive properties, extensive properties. So how these properties are they depend. So today we just see. So this isothermal and the reversible expansion of this ideal gas. So this is it is explained in this slide very well that adiabatic reversible expansion of the ideal gas. In adiabatic reversible expansion of the ideal gas, in adiabatic process, that is delta Q is equal to the 0. And according to the first law of thermodynamics, delta E is equal to delta Q plus W. This is equation for the first law of thermodynamics. So we get in first adiabatic process, we have already known that delta Q is equal to the 0. So delta Q and first law of thermodynamic, that is a equation of the first law of thermodynamic is, that is that delta E is equal to the delta Q upon Q plus W. So delta Q, it is substituted, is equal to the 0. If we is substitute with 0, then we get W is equal to the delta Q only. If work involved is the work of expansion only, then if dV is a small increase in volume and P is the pressure of the gas, then W is equal to the minus P dV. Putting this value in equation, we get delta E is equal to the minus P dV. And for the ideal gas, the equation becomes Cv is equal to delta E upon delta T, or delta E is equal to Cv dt. So by using this graph, we can also understand the adiabatic reversible process at adiabatic. What are the adiabatic conditions and the isothermal condition? We can understand. So if you have any queries or any problem with this Google Classroom, you can place in the comment section also. So thank you.